Lesson 3.2 Pre-Calculus Student Notes, Day 2. The learning targets for this lesson are to be able to solve logarithmic equations with multiple logarithms that can be condensed, and to be able to solve logarithmic equations with only one logarithm. To undo a logarithmic function, use an exponential function of the same base. We've done this before. Or if the bases are the same, the values inside the logarithm must be equal. So here's a couple basic problems. Some of these are similar, some of these are different. We'll take a moment to look at them and see which ones you think are similar. If you said A and B were similar, you are correct. On both sides of the equation, or both sides of the equal sign, you have a logarithm of the same base and no other operations. When we have this, we can simply set the insides equal, because if I have the log of base 5 of x and log base 5 of 3, and these are equal, then what's inside this logarithm must be equal to what's inside of the other logarithm. Same thing over here. 3x and 4x minus 5 have to be equal. Now, when you solve a logarithm, you do want to plug it back in to check for extraneous solutions, because we know we cannot have a negative number inside the logarithm. So we have to plug it back in to make sure that that doesn't happen. Here, when I solve, I subtract 4x from both sides. Negative x equals negative 5, which means x equals 5. If I plug that back in, it's 20 minus 5, which is 15. Log base 20 of 15 has a decimal value. It's not a negative inside the logarithm. 3 times 5 is 15, so I know it works. Log base 20 of 15, log base 20 of 15. The next two are similar in that there's only one logarithm and not really any other operations. We do have this cubed, which for this problem, I'm going to bring it to the front. Now I have an operation on log base 8 of x. So to get rid of that operation of times 3, I'm going to divide both sides by 3, and I'll have log base 8 of x equals 3. Now I don't have to deal with an x cubed after I do the logarithm. So to undo a logarithm of base 8, we have to use an exponential function of base 8. So I have to do 8 to this power equals 8 to the third. When I do this, I get x equals 8 to the third power. 8 times 8 is 64, times 8 is 512. So x equals 512. I should plug that back in to make sure it works. I'm not expecting it to not work, but I want to see what we get. Log, whoops. I'm going to do log, and some of you don't have this, so I'm going to do log of 512 to the third. That's what's inside the logarithm, x cubed, divided by log base 8, a log of 8, to get rid of the log, to convert to log base 8. And I get 9, so we have the right answer. On the next one, we have our natural log of x equals 6. To undo a logarithm, we have to use exponential of the same base. So I do e to the natural log of x, which is just x, and e to the 6th. So x is e to the 6th. If I hit second and the natural log key, I can find out the decimal approximation for e to the 6th. 403.4288. Unless it asks me to round to the nearest hundredth, I'm going to round to the nearest 10,000th. Next, we're looking at solving logarithmic equations that start out expanded. So our goal is to try to condense them to one logarithm on each side, or just to one logarithm if possible, and then solve. So if I can get them to look like this, then I can treat them like this problem. Or if I can get them to look like this, then I can treat them like one of these problems. So letter A. We have this, and remember, we always have to go back and plug it in to make sure. So we have an addition symbol on this side, so I have to do log base 2 of x times 4x, which is 4x squared, equals log base 2 of 64. I could get this to one logarithm if I want, but I don't need to. I have it as one log on each side, If there's addition or subtraction over here, then I can't do this, treat it like this. I'd have to deal with that addition or subtraction, try to make it into one logarithm on each side. So because they both have base 2, the insides 4x squared must equal 64, the inside of the other logarithm. When I divide by 4, I have x squared equals 16, which means x is plus or minus 4. Well, we'd have a problem with those answers. If I plug in 4, I have log base 2 of 4 plus log base 2 of 16. 4 times 16 is 64. So x equals positive 4 is fine. But x equals negative 4, if I plug that in, then this is log base 2 of negative 16, which is undefined, and log base 2 of negative 4, which is undefined. So that one is extraneous. You have to be careful of extraneous solutions. Letter B, also an addition problem. So again, I'm going to multiply the 3x with the x minus 1 to condense this to one logarithm. It is a log base 10. So log base 10 of 3x squared minus 3x equals log base 10 of 18. So since I have log base 10 on both sides and no other operations, whatever's inside this logarithm has to be the same as what's in this. 3x squared minus 3x equals 18. When I subtract 18 from both sides, I have 3x squared minus 3x minus 18 equal to 0. I'm going to factor out the greatest common factor of 3. And when I break this down, I have x by x and negative 3 by positive 2 multiplying to negative 6, adding to negative 1. Set each equal to 0, I get x equals 3 or x equals negative 2. It's okay for x to be negative as long as when I plug it in, the inside of the logarithm is positive. But when I go to do this with negative 2 minus 1 is negative 3. So this is extraneous. When I plug 3 in, this becomes log base 10 of 2 plus log base 10 of 9. 2 times 9 is 18. So this is the solution. And I can plug it into the calculator to verify as well. Next example, letter C. Again, an addition problem, so I have to multiply the 3 by the x minus 2, because that's what I do with the inside of the logs when I'm condensing, and there's a plus between them if they have the same base. So log base 4 of 3x minus 6 equals log base 4 of x. Equals log base 4 of x. So now that I have them to the same log, x equals 3x minus 6. Subtract 3x, negative 2x equals negative 6. Divide by 2, x equals 3. If I put a 3 in here and a 3 in here, this is 12, and this is 3. 3 times 12, I don't think is 64, so I think I did something wrong. 36. 3x minus 6. Subtract x is negative 2. Divide is, negative 3, or positive 3. Oh, this is the equal side. This is 3. This is 3. This is 1. So 1 times 3. No, it is balanced. It's good. Over here, they have the same inside or the same base, just a logarithm on both sides. X squared plus 3 equals 52. Subtract 52. I have x squared minus 49 equals 0. X minus 7 by x plus 7 are the factors. So x equals 7 or x equals negative 7. Some of you are saying, oh, one of those is extraneous. It might be, but if I plug in negative 7 and square it, I still get positive 49 plus 3 is 52. So in fact, there are actually two solutions for this one. They both make the inside of the logarithm positive and true. So don't just assume because it's negative that it won't work. Same thing with condensing these. I'm going to ask you to try some of these in class. I will look at a division one for you. We'll look at letter G. So I have subtraction of natural logs, so to get them together, I have 7x plus 3 over x plus 1 equals the natural log of 2x. Now, because the insides, because the natural logs are equal and no other operations, I simply have 7x plus 3 over x plus 1 equals 2x. We're going to have to multiply by the least common denominator of x plus 1, which means I have 2x squared plus 2x, and then I'm going to subtract 7x and subtract 3 to get it equal to 0. So I really have 2x squared minus 5x minus 3 equals 0, giving me 2x by x and 3 by 1, negative 6. Negative 6x plus 1x is negative 5x. Setting each of these equal to 0, I get x equals negative 1/2, or x equals 3. If I plug 3 in, I'm going to get positive numbers inside. If I plug negative 1/2 in, I'm going to get negative 1 here, which means this one is extraneous. It should be x equals 3. Let's try this on the calculator to make sure that it actually works. So I have natural log of 7 times 3 is 21 plus 3 minus the natural log of 3 plus 1 is 4. And that should be equal to the natural log of 2 times 3, which is 6. And they are the exact same decimal values, so I know I did this one correctly. You do need to check for extraneous solutions, especially if we have a rational equations. We had to do that anyhow. Now we have a rational with a logarithm, so I doubly need to be checking those answers. I'm going to have you try E, F, and H in class, so please hold on to those ones. Solving logarithmic equations with only one log, you saw that on the other side. However, sometimes we have to undo operations first. So in this case, I need to get the log by itself. I'm going to subtract 6 from both sides. 2 log base 10 of 5x equals 12. I also need to divide by 2 or move it up in squaring, but I don't like exponents, so I'd rather divide. Log base 10 of 5x equals 6. Divide by 5, and I can't divide by 5 because it's log base 10. So I have to do 10 to this power and 10 to the 6. Exponential function of the same base will undo the logarithm. So we're left with 5x equals 10 to the 6th, which is a big number. Hold on. It's going to be 1 million. And I will divide that by 5, and I get 200,000. Can plug that back in to double check. That's 6 plus 2 times log of 5 times 200,000 equals 18. 6 plus 2 times log of 5 times 200, whoops, 1,000 should be equal to 18, and it is. Same thing with this one. We're going to undo the operation, so I'll subtract 4 first. Negative 3 log of 5x equals 12. Dividing by negative 3 to get the log by itself, log of 5x equals negative 4. 10 to this power equals 10 to this power, since it's a log of base 10 that I'm undoing. 5x equals 10 to the negative 4th divided by 5. 10 to the negative 4th, make sure I'm out of the exponent, divided by 5 is 0.12345. There's 10,000, 100,000, 2 millionths. Hundreds, thousands, 100,000, 200 thousandths. Lastly, letter C. I'm going to subtract 4 from both sides. I'm trying to get the log by itself. I have negative 3. It's the exact same problem, so I don't know how I printed that. But this will conclude the notes for our examples. Again, please remind me tomorrow in class. I'm going to ask you to try a couple of these with addition and one with condensing when there's a division. This concludes the video notes for lesson 3.4 day 2. Our learning targets being able to solve logarithmic equations by condensing and by being able to solve logarithmic equations with only one logarithm. Have a great day.